start a turn. See how fast I can get it going. Okay, so what we've done, we changed this from an object at rest into an object in motion. So now it's turning. But this is where the exciting part happens, right? I'm going to take the flame away. I'm going to ask you the really important physics question that Isaac didn't realize. Here we go. 3, 2, 1. Okay. Will the ball spin forever? What do you think? No. But could the ball spin forever?
Could.
It could, yeah. Look at it. An object in motion will stay in motion forever. Something actually has to slow it down. So something's got to be slowing my ball back down, causing it to stop. So what's slowing down the ball? What do you think?
Gravity.
We got gravity. Temperature, not so much, actually. Doesn't even matter. If it goes cold, it can keep spinning. So something's got to actually be stopping it, slowing it down. Yeah, so we got gravity. What else?
Friction.
Friction, right? Where?
From air?
Yeah, we got friction with the air. That's drag, so it's bumping into the air. It's also got parts of the chain are rubbing together. So where can we put the ball where there's no gravity, no friction, and no air? Space, right? So when we put rockets in space, they actually never stop. Even once we run out of fuel. This is a rocket, I'm flying through space, and I shut off my rocket engine. It's just going to keep going and going and going because it's an object in motion. So when we take rockets and we put them in space, even once they run out of fuel, they'll never stop. They will just go for eternity into the cosmos. We've actually done this with one of them. It's called Voyager. And when we sent Voyager out into space, we got it to take some pictures out there. I don't know if I actually have the photo anymore. Let me find it. So here's one of the pictures from Voyager, and it's called the pale blue dot. On the dot. And if I zoom in on it, all right, everyone have an idea of what that dot is? That's Earth, yeah. It's the most distant photo of Earth ever taken. It was taken by our spaceship without traveling through space. And it's still going. That spaceship will never stop. It's also got a record on it. There's a bunch of languages from Earth, people saying hello. It's got a bunch of music from planet Earth, and it has a map on how to find us. Is that a good idea? I don't know. I guess we'll find out. Okay, so close that one down. So objects in rest will stay at rest, and an object in motion will stay in motion. Two tubes. And both of the tubes in the air cannon are going to shoot the same amount of air. So we've got the same amount of air coming through both tubes of the air cannon. And I have two different balls, but those balls are not the same. One of them is a bit different than the other. So, let me get you to weigh these for me. Hang on to that one, and then hang on to this one. What's the difference between them? That one's heavier than that one, right? So the red one's heavier. Did I pay you to say that? Have we ever met before? Okay, so we can trust you. Okay, that sounds good. Okay, so red ball is heavier than the green one. So I'm going to put the red ball on one side, the green ball on the other side. All right, plug those in. I'm going to close these doors so I don't kill anybody. There we go. Same amount of air hitting both balls. One ball is heavier than the other one. So which one do we think is going to go farther, faster than the other? Who votes green ball?
Red.
Who votes red ball? Oh, the adults have to go back to school. Okay, here we go. 3, 2, 1. Whoa. One. Of course it did. It was lighter. Lighter things are easier to move around. Let's think about this with rockets. If I have a heavier rocket, I need more energy to get it off the ground. If I have a lighter rocket, I need less energy to get it off the ground. So what do we think is heavier? Rockets with robots or rockets with people? You say people? Oh, you're right, actually. Well, why? Why would you think? Let me ask you this. Do robots need food? Do they need air? Water? Yeah, so when we send people, we have all this extra stuff we also need to bring with them. So the biggest and heaviest of all the rockets we've ever made have been the ones to get to the moon. And we are going back to the moon next year. Anyone know that? Jeremy Hansen was selected to go to the moon because he's an F-18 combat pilot and an engineer, but I think he might have been also picked because he looks like a real-life version of Buzz Lightyear. Right? Tell me that's not a Buzz Lightyear ship. Yeah. Okay, so what law of motion was this one? What did we learn from the two laws? So what we've learned is that. Second law of motion. Force is equal to mass times acceleration. Now, if all the fuel comes out of the rocket on this side, which way is the rocket going to go? That way, right? Equal but opposite reaction. So fuel goes that way, rocket goes that way. Okay. This is die wire. Put that in. Make it nice and tight. Now, along the wire, I've got this tube. That's what I'm going to attach the rocket to, so the rocket can slide along the tube. Now, got to give the rocket some fuel. Now, the rocket fuel burns, but it burns very slowly. So what I want is a nice fast rocket burn. So I don't want the liquid. What I want is the vapors from the liquid. So what I'm going to do is give it a shake to get the vapors out. Fill that bottle with gas. Okay, now we can attach the rocket to the wire. One and two. Whew. We all set? Okay, here we go. I'm going to launch the rocket off. Fuel's going to go this way. Bottle's going to go that way. It's going to be fast. It's going to be loud. If you don't like loud noises, you might want to cover your ears. Okay, here we go. Rocket launch in 5, 4, 3, 2, 1. Woo! But if you do want to be a rocket scientist, or rather an astronaut and actually get in a rocket, we're going to be sending more and more people in rockets to space all the time. Especially in places like Mars. So by the time you grow up, you graduate from school, and you as well, we might be going to Mars. So you might be one of future Martians. And if you go there, send me a postcard, because I want to know that once people from my show come on the way to the red missions, because we're building some of the components that are going into that new space mission. Speaking of moon rocks, we have one out in the gallery space, and you can touch it. It's one of only 5 touchable moon rocks in the whole world. So make sure you go and touch that moon rock. If you rub it the right way, it goes